what you should have done, okay, for these two, was we should have looked at sulfur. Sulfur's in group what? 16. So what's his charge? -2. Good. All right, so we're going to throw a little -2 up there. How many sulfurs do I have? There's only one. So my overall negative charge on this side is a what? -2. Therefore, in order to neutralize it or make it 0, what does manganese have to have? +2. All right, so what we call him is we go manganese 2 sulfide. Did you also double check that you're ending with an "ide"? Okay, make sure you did that. Yes, sir.
I just wanted to ask if the name of the compound would be manganese monosulfate.
For this?
Yeah.
No, sulfate is a polyatomic ion. That's SO4 with a 2- charge. And you don't say mono on an ionic. Prefixes are not for ionics. But good question. Okay. All right. So the next one, we had sulfur again. What is sulfur's charge? -2. How many of them are there? So what's the overall charge over here? Good. So what does tin have to be to neutralize? +4. Awesome. All right. And so we would call this tin 4 sulfide. How do we do? Thumbs up, thumbs down? Okay. We'll practice a couple more of those in a minute. All right. So next one I want you guys to do. All right. So this is oh man, just a second. There we go. All right. So for this one, you need to first ask yourself, is it ionic or covalent or molecular, whatever. And then I want you, if it's ionic, you're going to model it, as in you're going to do the transfer of electrons, so the thing on the first page of your notes. Okay, so you'll model it with the transfer and the brackets. If it is molecular, you are using NAS system, and you will figure out what the Lewis dot structure is and draw it. Okay? And then, so I'm asking a lot right now, I want you to name it. Okay? So it's a lot. If you want to kind of get with a partner and work together on this one, I have no problem with that. It's a lot of questions. Good to have a couple brains. Make sure you know what you're doing, though. Don't rely on your partner. I'm just going to go over it real quick. So for carbon, first of all, sorry, this was covalent, so we do use our prefixes. So what did we call this?
Carbon monoxide.
We did. We called it carbon monoxide. Good. Okay. So, just put that in. All right. So when you guys went to go draw it, all right, it should have bothered you a little bit because when you did your needed, available, shared, you had needed was an 8 plus 8, so 8 for the carbon, 8 for the oxygen, so you had 16 total. Available, you had 4 and 6. Those were the valence electrons, right? So that equals 10. 16 minus 10 is 6. We divide it by 2 for every bond, so we had 3 bonds. It should have bothered you that you only have 2 things here and you need to use 3 bonds. So what you're going to do with that is you just, when things bother you, just write out all the letters. Just seriously put all the letters in front of you, kind of put them in some sort of an organized shape, all right? This is only 2, so you have 2 there. We're going to throw the 3 bonds in between them because that's what it tells us to do. Now you have to double check, are these guys all satisfied? What is the satisfied number? What do they want? 8. They want 8. You're good. We're going to get to that number in a second. All right, so far oxygen has 2, 4, 6. He needs 2 more, so he has 8. Carbon has 2, 4, 6, 8. Okay, so now everybody's happy. Last step, double check that you matched your available number. Because when you get to AP chemistry, you're going to get extra electrons thrown in there, okay? And it gets more complicated. But first you have to satisfy everybody on the outside, and then you worry about the stuff on the inside, okay? So here we're going to just double check. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're good. We're done. This is carbon monoxide. This is a deathly gas. Anybody seen or heard of like carbon monoxide sensors or the little alarms and stuff? Yeah. Bad stuff, man. All right.
How is it that carbon monoxide is such a quantity because of the way the work it
Comes from propane.
We have so much in common. It's crazy.
So typically it's what's come. So it's a version of your like. I should not be recording.
The AP one, miss.
So we're going to do PCl3. So for this one, you should have, what is this guy called, by the way?
I don't know.
Phosphorus.
Trichloride. Yeah.
That looks like fry. All right. Trichloride, good. So after that, what you guys should have had for NAS, go ahead and yell it out to me. 32, 26. We had 6 divided by 2, which was 3 bonds. Yes? Okay. How did you know everybody needs 8 and there's 4 atoms? There's 4 atoms total.
Oh, you multiply?
Yes. Well, or you do 8 plus 8 plus 8 plus 8. Right? All right. So, how did you guys know to put phosphorus in the middle? Because a lot of you guys did. You just did it. And that's cool. How did you know? What did you do?
Because phosphorus is the one sharing with chlorine. They're not sharing with each other. So they all share with phosphorus to combine to make the compound.
Okay, so you're going with the idea that phosphorus has more single electrons. That's good. Okay, yes? It's closer to carbon. Good. All right, so your rule of thumb, and it all comes back to that, all right, just so you know, because carbon has 4 open spots, right? So the whole idea is that you go with the least electronegative. Who's the most electronegative? Fluorine. So try and go as far away from fluorine as possible. So the next one that I'm about to have you guys do, make sure you keep that in mind, okay? Also, whenever you have a bunch of things and only one of another, put the one guy in the middle, all right? And for the most part, you can use that rule when there's only 2 atoms. So once you got that, you had P, Cl, Cl, Cl. Fill up of all of your Cl's with 8. And then you should have noticed that that only makes 24, so you put 2 on the phosphorus. What this creates is something that looks like this. And you guys will have a chance on Friday to build all these. Aw, man. It's okay. I got this one. Just hold it for a second. It's gonna look like this, all right? And then the lone pair kind of sits on top and pushes those guys down. All right? So it's kind of like this. Cool? Cool. All right, erase your boards. Let's do the next one. Okay, you guys wanted the AP one? No, let's do this one and then I'll do the AP one. So this one I want you guys to do is SO3. This is a little difficult. Okay, but give it a try. I forgot to record. So we had sulfur trioxide. So when we use NAS, the needed, how many does everybody need? Well, 8 each. There's 4 things there, so it's going to be 32. And then available, sulfur and oxygen are both in group 16. So how many do each of them need? 6, or have is 6. So 6 times 4 is going to be 24. 32 minus 24 is 8 electrons that have to be shared. 2 per bond. So we have 4 bonds. That should have bothered you, because we only have 3 things that we're trying to connect, and we have 4 bonds that we have to squeeze it between. So, what? Oh. So, what we're going to do is we're going to throw sulfur in the middle, draw 3 oxygens, draw my 3 bonds, and double up one of them. Okay? And then at that point, let's make our oxygens happy. So this has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Okay? And then you're done. Sulfur does not get any lone pairs. The way that you check that, you go back through and count them. This had 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That was all we had available. You can't put extra ones on there. In AP chemistry, you would throw extra ones on top of that central atom. Whatever you have left over goes on the central atom. Okay? So that's what you have to look forward to later. All right, cool. So before we're done, let's go ahead and do this one. Maybe. Here it is. Ah. All right, let's do this one right here. Who is this? So is this NAS? No, because we have a metal and a non-metal. So what kind of compound is this? Ionic. This is stock system again, so go ahead and work it out. Okay, so this is stock system all over again. Listen up. Shh. All right, so we take a look at our anion. Phosphorus has a what charge? Phosphorus has -3. How many of them are there? 2. So what's the overall? -6. What does it have to equal over here to be a 0? +6. So there's +6 divided by 3 things. What is each one of them? +2. You do 6 divided by 3 equals 2. So this would actually be called nickel 2 phosphide.
Not phosphate.
Nope, phosphide. Phosphate is a polyatomic. We do not want to confuse that. All right. Okay, so you guys did a great job today. Please put